Hello one and all, welcome to the Math Magic Show. In this one we're going to answer the following question. Open top box, let's have a volume of 100 cubic inches or some volume. Find the minimum surface area. Okay, so let's take a look here. Imagine this is the bottom of the box. That's X and that's also X. That's also X, that's also X. So each edge there is X units. It could be 5, 10, whatever, we don't know. Okay, then we got to put the sides. So this is like as if you had a box and basically opened up the sides. So this is the bottom, the yellow, and then the sides would go around the bottom. So I would give you y, for example, okay? And that would be another y, another y. So the y is basically representative of the height of the box. If you took those blue sides and you folded them up, it would give you an open top box. Okay, and that's also y. So that means the following based on this, that x squared represents the area of the bottom piece, okay? That xy represents the area of that side piece, opened and laid flat. That also represents now the area of the side piece, another xy for another piece, and then another xy for another piece. So we've done all of this because now we can build up our area function as follows. Take a look. It's going to be the following. That a equals the following: xy plus another xy plus another xy plus another xy plus x squared. We can simplify this because, as you can see, the term xy is there 4 times. So we can just write 4xy plus x squared, where the 4 simply is the coefficient that tells us there are 4 sides labeled xy. That's all the 4 means. Okay, based on that, I can do the following next. The volume is a given quantity. So I'm going to say that x squared times y. And I know that because once you fold up the sides, it becomes a box. So you would have x times y, which would give you x squared y. That would be the volume, okay? With the top missing again. So then the following is true. I can say x squared y equals 100. And that is from the given statement of the problem where it says it's to have a volume of 100 cubic inches. The fact that it's of 100 is not special. It could just be in general, like for example, A or B, just some number, okay? But here, to make it more concrete, I just randomly chose 100. It could be 50 or 200 or 1,000. Now, from there, what we can do is the following. We can divide both sides by the following: x squared, and then also on that side, so it becomes 100 over x squared. This is assuming that x is not equal to 0, because that would give a 0 squared, which is not defined in terms of division. And I'm doing that because now I can say the following. I'm going to cancel off the x squared that's on the left side, and I'm going to have here y equals 100 over x, and I can take 100 over x squared and plug it in to the basic 4xy plus x squared. In other words, I can take my expression for the area and rewrite it in terms of only one variable, since we are working here within the context of one variable calculus. So at step 6 across the top, I'm going to have a of x now equals 4x times 100 over x squared plus x squared. So what I've done is I've taken the y from step 1, where it says 4xy plus x squared, and I've replaced the y with 100 over x squared in step 6. And also notice that I've added a of x now to be very clear that this is now a function of x. Okay, now let's simplify this a little bit. When you transition to step 7, it's going to give me the following. Now a of x equals 4x times 100, and then 1x is really x times x for x squared plus x squared. I want to do that because now I can see that I can cancel off that x and that x in a pair, which at step 8 is going to give me the following. Now a of x equals 4 times 100 over x plus x squared. Okay, so that's going to give me the final function as a of x equals 400 over x plus x squared. And that represents the area of the box, the area function, if you like. Now, we are operating here within the context of one variable calculus. So for that reason, what I'm going to do is differentiate this. Let's go through that step carefully. So first, I'm going to rewrite it as follows. A prime of x equals dy dx, or just d over dx, of 400x plus x squared, the way you see it. I'm going to differentiate the expression on the right side. Let's rewrite it though first. I'm going to have a prime of x equals d over dx, and then I'm going to write it as 400x to the negative first plus x squared. And I'm writing that x in the bottom at step 10 and step 11 as x to the negative first, and that's actually differentiated. So it's x to the negative first that can be done with the basic power rule. X squared can also be done with the basic power rule for derivatives. So it's giving me the following here. A prime of x equals 400 times negative 1, bring that down, times x to the negative 1 minus 1, subtract 1, and then plus 2 times x to the 2 minus 1, subtract 1, bring the 2 down. Step by step, let's simplify a little bit. So it's going to be a prime of x equals negative 400 times x to the negative second plus 2 times x to the positive first, which is normally, of course, just written as x. That is our derivative. Now, you very likely know by now, given where you are in your mathematical studies, that the derivative should be equal to 0. So in other words, I'm going to take that expression negative 400x squared plus 2x and set it equal to 0 to find the value where that function, the derivative function, crosses the x-axis basically, because at that value, that also corresponds to the minimum value of the area on the graph of 400 over x plus x squared at step 9. So let's continue on to the next step. 15 here, I'm going to do the following. I'm going to take negative 400x to the negative second. I'm going to divide it by 2x on both sides. And remember, I'm setting that equal to 0. So back at step 14, if you look carefully over here, I had 2x in that position, that second term on the left side of step 14. So that's why I'm dividing by 2x. And again, I'm assuming that x is not equal to 0. So for that reason, I can divide by 2x on both sides. Okay, I'm assuming x is not equal to 0 because when x is 0, that's not a valid move because 2x over 2x would be 0 over 0 once you plug in x equals 0, and it wouldn't work, would not be defined. So I'm assuming x is not 0, okay? So I can divide that way. Now, on the right side, 0 over 2x will be 0, 2x over 2x will be 1, and the negative 400 over 2 will give me this. Take a look. It's going to be negative 200 times x to the negative third plus 1 equals 0. When I transitions from 15 to 16, it works this way because x to the negative second divided by x becomes x to the negative second minus 1, which then becomes x to the negative third by the basic laws of exponents. 2x over 2x is 1, goes away, 0 over 2x is 0. Okay, continue here. So 17, I'm going to have negative 200, x to the negative third equals negative 1. Add, subtract 1, then I'm going to have negative 200 over x to the positive third equals negative 1. Then basically this is a proportion at this point, so you can kind of do what we call cross multiplication. It's going to tell you that 200 equals x cubed. And then based on that, you take the cube root, so it's going to give you the cube root of 200 as the value of x. And that is approximately equal to 5.848 inches. That's the approximate value of x. In other words, that value tells you what should be the dimension over here in the picture on the left side of x right here. So that should be about 5.84 inches, like that. That should be the area of that base yellow square. 5.848 by 5.848. Okay, for each of those sides, in other words, a square. Now, once you know that this is the value of x that minimizes the area function, what you want to do is actually find that area, and you do that by taking that approximation, say, and plugging into step 9, which represents the actual area function in terms of x only. So it's going to give me at step 22 down below, a of 5.848 equals 400 divided by 5.848 plus 5.848 squared, and that is approximately 102.6 inches squared. That is the estimate there of the smallest area you can find, given that the volume is 100 cubic inches. Okay, and that is it for me. I hope this has been something helpful and insightful. I've tried to break all the steps down into great detail and then number all the steps so the flow was clear. Thank you so much for watching.